perfect square trinomials. A perfect square trinomial is a trinomial that can be expressed as the square of a binomial. So if I have x squared minus 10x plus 25, if I factor this, I would see that I get x minus 5 times x minus 5, which is x minus 5 squared. So as the second example, if I have a squared plus 8a plus 16, if I factor this, I would see I get a plus 4 times a plus 4, or it turns out to be a plus 4 squared. And the third example, p squared minus 14p plus 49. If I factor this, I get p minus 7 squared. You notice that the constant, this constant terms, the numbers here, 25, 16, 49, is the square of 1/2 the coefficient of this term x. So if I take this coefficient of x, negative 10, and divide it by 2, find half of that, and then square them, what do I get? 25, right? So as the second one, look, if I take the coefficient of a and divide it by 2, find half of that, and square them, what do I get? 4 squared, which is equal to 16. So it just turns out that this constant here would be always equal to half of this coefficient of a or x square of that. So in this case, this 49 is minus 14. That's the coefficient of p. If I divide that by 2, what do I get? 7. And when I square that, what do I get? 7 squared would be 49. So we're going to use this concept to make any trinomial into a perfect square. Why do we need to make it into a perfect square, anyone? Right, if I make something a perfect square is equal to a number, then I can use the square root property to solve them, because then I can say x equal to plus and minus square root of k. So that's the reason we need to do that. So once again, if I have a trinomial like x squared plus 10x plus n is unknown, what n should be in order to make this a perfect square? We'll take the coefficient of x, which is 10, we divide it by 2, or multiply by 1/2, and then you square that, 25. So 25 not only make this trinomial factorable, also would result into the same binomial here. Remember, x goes here, x here, when we're going to factor this. For 25, the possibility would be 1 and 25, 5 and 5. Looks like 5 and 5 is the one we need, because 5 plus 5 is equal to 10. So this would be both positive. You see, that would result into this binomial square. So what I'm going to do now is to ask you to find the n for these 4 examples. For those of you watching this later, I suggest you pause the session right now and see if you can get the same answer that we get after we solve for this. Okay, let's take a look at all these. All right, let's take a look at the first one. You take the coefficient of x, which is equal to minus 12, and you divide that by 2, or you multiply by 1/2, you get minus 6, and you square them, and you get 36. So we need 36, and as you see here, if I have x squared minus 12x plus 36, when I factor this, you get x, 6, 6, both minus, that give you minus 12. You notice that this number here, 6, is always the same as absolute value of this number before you square them. That's the observation. So when you factor them, you would get, in this case, x minus 6. That would be the square root of this number that you added. Okay, next one. You take minus 10, you divide it by 2, and you multiply 1/2, you get minus 5. When you square that, you get 25. So you notice that you always add a positive number, because once you square them, you always get a positive number. So x squared minus 10x plus 25, I factor that, I get x minus 5 times x minus 5, or x minus 5 squared. Next example, 7. If I take 7 and divide it by 2 or multiply by 1/2, what do I get? This time I get a fraction, 7 over 2. How many of you had a problem with this one? Okay, looks like a few of you got stuck here. It's okay to get a fraction. That's all you have to do is just square this. When you square that, you would get 7 over 2 squared would be 49 over 4. So you add 49 over 4 here. Now let's take a look at this. I would get x squared plus 7x plus 49 over 4. Now if I factor this, you notice I get x and x, and this number should be square root of this, which is 7 over 2, 7 over 2. So if I multiply the two closest term and two furthest term, what do I get? 7/2 x here. I get 7/2 x here. What is 7/2 plus 7/2? Which is 7/2 plus 7/2. That give you what? 14 over 2, which is equal to 7. So everything is there. Next example. When I take 5 over 4, multiply by 1/2, what do I get? 5 over 8. When I square this, what do I get? 25 over 64. So you need to add 25 over 64 here to complete the square. So it's not always a whole number. Sometimes you get a fraction. So in this example, I get x squared plus 5 over 4x. If I add 25 over 64 here, then this would be not only factorable, also would be the same binomial here. I get x here, x here. Remember, the square root of the number that you add goes over here, which is equal to what? 5/8. Now, what is 5/8 plus 5/8? 5/8 x here. You have 5/8 x here. If I add 5/8 plus 5/8, 5 plus 5 is equal to what? 10/8. If I reduce this, what do I get? 5/4. That's exactly what I wanted. Right there. It was 5/4. So with this method, I can take any trinomial and convert it into perfect square. The binomial which is perfect square. That's all I need is the right constant here in order to do that. So if you give me any trinomial, I don't really need the constant that you're giving me. I'm going to move it to the other side. And then look for the constant I need to complete the square. But there's one restriction involved with this, and that is the coefficient of x squared has to be equal to 1 in order to be able to use this method. So if the coefficient of x squared is not equal to 1, then we need to eliminate that coefficient, which we're going to look at some examples in the next session.